Hi, welcome to King at Math on exponential and logarithmic graphs. The most fundamental exponential graph is y equals e to the power of x as shown in blue. This graph intersects the y-axis at the value of 1. Moving on, y equals the product of 3 and e to the power of x, which is shown in red, would have its y values being 3x, the y values of y equals e to the power of x with reference to the x-axis. This graph will intersect the y-axis at the value of 3. As for the yellow graph, expressed as y equals e to the power of x plus 4, all of its points are a translation by plus 4 in the y direction from the y equals e to the power of x blue graph. This graph intersects the y-axis at the value of 5. As for the green graph, which takes on the equation y equals e to the power of 5x, when you compare this to the y equals e to the power of x graph, all of its points takes a higher value of y for when x is larger than 0, but the point is exactly the same when x is equals to 0, and all of its points take a lower value of y for when x is less than 0. I'm going to switch gears to talk about logarithmic graphs, starting with y equals log of x with base e. This is the inverse of y equals e to the power of x. As in all inverse functions, they are a reflection of one another against the y equals x line. And this log curve intersects the x-axis at the value of 1. It heads towards positive infinity as its x heads towards positive infinity. It heads towards negative infinity as its x heads towards 0. And it does not have any negative x values. The most fundamental logarithmic equation is y equals log of x, and this graph intersects the x-axis at the value of 1. For the blue graph, which is expressed as y equals log of x plus 4, all its points are a translation by plus 4 in the y direction from y equals log x. As for the red graph, expressed as y equals the log of bracket x plus 4, all its points are translation by negative 4 in the x direction from y equals log x. The graph intersects the x-axis at the value of minus 3. For the yellow graph, expressed as y equals log of 2x, the graph intersects the x-axis at the value of 0.5. And finally, for the green graph, expressed as y equals the product of 2 and log x, when compared to log x, all its points will double in its value of y, except for the point where x is equal to 1. Now let's get on to tutorial question 1, where we are to sketch for the y equals exponential expression. With its exponent being of a negative value, the curve would be a reflection against the y-axis of its usual exponential curve. And in finding that when x equals 0, its y value is minus 2, and when y equals 0, we could solve using the conversion into log as x being equal to minus 0.23, and knowing that as when the exponential function nears 0, y nears minus 4, we could plot the graph as shown on the right. Tutorial question 2. Sketch the graph of y being equal to a log expression. The curve will take on the usual curve of a log, and when its x is 0, its y can be calculated as being 6.44, or more precisely as 4 log of 5. And when y is 0, that's when log 1 is equals to 0. We could identify 2x plus 5 as being equal to 1 to solve for its x as being minus 2. And finally, as y nears negative infinity, 2x plus 5 must near 0, which implies that x must near minus 2.5. This would then allow us to plot the graph as shown on the right. Tutorial question 3. Find the inverse of the exponential function. As in finding the inverse functions of any sort of function, you start by letting y being equal to the function, then express x in the form of its y. The inverse function would be equal to this form, with its y being replaced by x. Tutorial question 4. Find the inverse function for a function that's equated to a log expression. Again, you start by expressing y as being its x value and rearrange its construction in order to obtain x in the form of y, and from there be able to identify its inverse function as being in this form with its y converted to x. That's all for the second and final part on exponents and logarithm. If you found this beneficial, please do seek out our other videos under the KT tutorial channel.